Great, we're supposed to find all the real zeros to the function. So I can use the rational zeros theorem to list out all the possible rational zeros. Okay, so what that means is it's factors of the first number divided by all the possible factors of the last number. So of the first number, I said that backwards. Factors of the last number divided by all the possible factors of the first number. So look, factors of 10, positive or negative 1 would work. That wouldn't give me any decimals if I divide 10 by 1. Positive, negative 2, those are factors of 10. Positive, negative 5, those are factors of 10. Positive, negative 10, those are factors of 10. And then the leading coefficient's 1, so all the possible factors of the 1, it's just positive or negative 1. Okay, the rational zeros theorem says, hey, if you partner up this number and this number, the negative version of this number and the positive version, the negative number and the negative number, the positive and the positive, the positive and the negative and the positive, the negative and the negative. Okay, you get the idea. If you write out all those possible fractions, those are all the possible rational zeros. Okay, so we could have 1 over 1, we could have 1 over negative 1, we could have 2 over 1, we could have 2 over negative 1, we could have 5 over 1, we could have 5 over negative 5, negative 5 over 1, and we could have 10 over 1 and negative 10 over 1. Those are all the possible real rational zeros. Okay, and so what you really need to do is start off by finding at least one of these that work. Okay, which means plug in 1, see if it makes 0, and if it doesn't, forget about it. We'll look for another one. So if I plug in 1, 1 to the fourth is 1. 1 minus 1 makes 0. 0 minus 7 is negative 7. Negative 7 plus 5 is negative 2. Negative 2 plus 10 makes 8. That doesn't make 0, so that's not one of our zeros. Repeat the process with negative 1. If I plug in negative 1, that's 1 minus a negative 1, so that makes 2 right now. 2 minus 7 makes negative 5, we're here. Negative 5 minus 5 makes negative 10. Negative 10 plus 10 makes 0. This is winner, winner, chicken dinner. If you plug in negative 1, you get a 0 out here. Now what that does for us is it tells us what we can factor this by. This polynomial can be divided by x plus 1 because this negative 1 is a root of this divisor. Okay, we're going to be able to rewrite this as x plus 1 and then a bunch of other jazz going on over here. But if you plug in negative 1 in here, that turns the whole thing into 0, right? And we just saw that that has to be the case because we plugged in negative 1 into the original function. Okay, so look, this is what we're going for. We're rewriting this thing. We're factoring it. We're going to take out an x plus 1. We need to know what all that jazz is that I was talking about over here. And so to do that, we've got to use synthetic or long division. So negative 1 is our root. That's the thing that makes it equal 0. I'm going to copy down the leading coefficients. And just check out a video on synthetic division if you're lost in what I'm doing here. Carry down the 1, and then I'm going to do negative 1 times 1 makes negative 1. Add the columns. Negative 1 times negative 2 makes 2. Add the columns. Negative 1 times 5 is 5. Add the columns. Negative 1 times 10 is negative 10. Add the columns. Look, that wasn't by accident. There's no remainder. Okay? What we just found out is all that, the thing I keep saying is all that jazz is this stuff right here. Sorry, it's x to the third minus 2x squared minus 5x plus 10. That's what goes in this parentheses. And the reason is because I divided this by x plus 1. And this is my result. If you were to multiply these two together, it'd turn back into this. Money back guaranteed. Unless, I guess, I could have screwed up. But okay, now that's great. We found one of the zeros. Look, there's something called the fundamental theorem of algebra. And it says that the number of unique possible solutions here is 4. That would make this equal 0. We found one of them. That means there's 3 more to go. Okay, so that means we need to find the other zeros from this information. And I can't tell right off the bat because it's a trinomial. That's not easy to factor. Oh, this one you could factor by grouping. But I'm not going to do that, okay, because you can't always factor by grouping. So we want to break this down further. We've got x plus, oh, I dropped my 1 here. We've got x plus 1. We want to break it down to another linear factor so that we can get this into quadratic land, then we can use our quadratic trick. So let's go look through our list and find out if there's another 0. And you might be groaning, you might be thinking, man, do I have to plug in 2 back into this whole thing? No, you could just plug in 2 in here because if this is 0, then 0 times all this is also going to be 0. So let's plug in 2 in here. That's going to give us 8 minus 8 is 0. Negative 5 times 2 is negative 10. Negative 10 plus 10 is 0. Man, I just got lucky. I plugged in 2 and I got a 0. That means x minus 2 must also be another linear factor. Because look, if you plug in 2 into here, 2 minus 2 makes 0. And 0 would distribute to everything and make everything else be 0. So 2 is another root. Okay, but we got to break it down further. So I'm taking this and I'm dividing it by x minus 2. And I'll write what's left over right here. So we got to use synthetic division again. So 2 is my root. I'm using this as the thing that's being divided. So here's my leading coefficients. Okay. And then let's do synthetic division just like we usually do. Copy down the first one. 2 times 1 is 2. Add the columns. 2 times 0 is 0. Add the columns. 2 times negative 5. Look, there's no remainder. And I could have told you that's going to happen because we already checked to make sure that 2 is a root. Okay, remember descending powers. This was x to the third, so now this is going to be 1x squared plus 0x minus 5. So in other words, x squared minus 5. Okay, I know it's a lot. That's why we broke this up into 2 separate sections, and we'll probably give you another day on it, okay? This is a root. We plugged that in and it made 0. This is a root. We plugged that in and it made 0. Now there's 2 more because there's 4 possible ones, and we get those from this quadratic over here. Look, you can set that off to the side. What would it take to make that quadratic equal 0? This one is a nice and easy quadratic. You just have to add 5 to both sides and then take a square root to cancel out a squared. And every time you use a square root to cancel out a squared, we got to remember positive or negative over here. So now it's like we've thrown the ring into Mordor, or whatever that is in Lord of the Rings. We found our final answers. X equals negative 1, x equals 2 are roots, and x equals square root of 5, and then x equals negative square root of 5. Those are all the possible real zeros for this function. We found all 4 of them.